Okay, so today we're going to talk about balancing redox reactions. And these 6 steps are what you're going to do every single redox reaction. Every single one. Okay, so you can see here we have a reaction below. And what we're going to do is I'm going to break it down step by step. And we're going to use every one of these steps. Okay, so let's start. I'm going to try my best also to fit everything in one page. Okay, but what I'm going to have to do is shrink the steps. Okay. Now the first thing is, and the very most important step where you're going to use your oxidation numbers, is you're going to split this reaction in black into 2 half reactions, meaning oxidation and reductions. Okay, but before we do that, there's a little pre-work we have to do. And this is where I like to have my different color pens. Okay, so the first thing I do is I am going to take what I learned yesterday with my charges and I'm going to put them all above each compound. So I'm going to go through every compound, every element within the compound, and put the oxidation number, just like we did in the warm-up. Okay, so that's my first step. Okay, so I am on step 1. I'm on actually some 3 steps here. Okay, so this is where I am. Okay, so the first thing is I'm going to look at H2S. Okay, sulfur has a -2 oxidation number. Let me do it in a different color. Okay, hydrogen, -2. Hydrogen has +1 times 2 is +2. Okay, and of course +2 minus 2 equals 0, so that works out. Okay, now oxygen we know is -2. I'm trying to write nice, which makes this -6. Okay, but it's, remember, this is an ion, so it's not going to equal 0. It's got to equal -1. Okay, so that means that the nitrogen is going to be a +5. +5 minus 6 is -1. Okay, sulfur is elemental, is an element. Okay, it's going to be a big old 0. Okay, and nitrogen and oxygen, oxygen's -2, which means the nitrogen is +2. Okay, that was my first pre-step. Now, what I'm going to do is look at these oxidation numbers and figure out which element was oxidized and which element was reduced. Okay, so for me, I write my oil rig down. Okay. And before I even do that, I look at my oxidation numbers and see which one changes. Okay, well, hydrogen is not even on the other side of the equation, so I don't have to worry about that. Okay, let's look at sulfur. Sulfur starts out at -2 and it goes to 0. So something changed. So before I even figure out whether it was oxidized or reduced, I just draw a line to it in one of my colors. It went from a -2 charge to a 0 charge. Something happened. Okay, now let's just look at oxygen for a minute. Okay, oxygen's -2, it's still -2, so nothing happened. Let's look at nitrogen. Okay, let's use a different color. Nitrogen is +5 on the left, and it's +2 on the right. So nitrogen is going to be my second thing that's going to change. So that's what I do first. I figure out where the numbers change. I don't even think about oil rig yet. I just want to point out where things are changing, where the charges are changing. Okay, now my next step is going to be, okay, which one is oxidized, which one is going through oxidation, which one is reduced, which one is going through reduction. Okay, so I look at my oil rig. I say to myself, well, oxidation is losing electrons. Okay, so let's look at the sulfur. -2 to 0. Is that losing electrons? Yes. because you do a +2, you're losing 2 electrons. So then once I decide that, I write down, I literally write it out, okay? Because I like to be very clear, and I want you guys to be clear what's going on. So I write sulfur is oxidized, okay? And I literally write it down, and a lot of times in parentheses, I want to confirm my theory, and I say lost 2 electrons. I actually write it out, and I'm not joking, just to be clear, because I think this can be confusing. So I want to just work it out in my brain and say, okay, sulfur is oxidized, it lost 2 electrons, and oxidation is losing. Okay, now, supposedly, by process of elimination, the nitrogen is being reduced. It's going through reduction, but let's double check. If it's going through reduction, it's gaining electrons. Okay, so let's look. So nitrogen is going from a +5 to a +2, which means it is gaining 3 electrons, right? It's gaining that -3, 3 negative electrons. So I can safely say that nitrogen, let me put it in purple, is reduced. It is gaining 3 electrons. Okay, and I just do that so I don't make a silly mistake, and I have to think about it again and count how many it's gaining, just so I'm not, making the wrong choice. Okay, to me, that is the hardest part. Okay, so that's kind of like your pre-steps before you get to step 1. You put all the oxidation numbers on, you match what's changing, and then you decide which one is losing, which one is gaining. Are we okay on this step? Okay, now I want you guys just to watch, and then if you want me to stop and we can write it down at the end, we'll do that, okay? So now I am actually on step 1. I'm ready. I am going to split it into 2 reactions. So all I'm taking is the blue, okay? And what I do is I just make a little heading. Okay, so I'm just going to okay, so first, okay, so I'm going to split it. I'm doing step 1 then, and then half of that. Okay, so first, yes, sure. I don't know where my mic is. Can you hear me now? Can you hear me now? Okay. This is my mic. What's the mic? Or not the speaker? I don't know. Okay, sorry about that. Okay, because it'll also be my arm blocks things too. Okay, so now I'm going to write down oxidation. So I'm going to make a little, I'm sorry I'm being slow, but I'm just trying to make that in my brain. It's hard to write on. So first I'm going to write the oxidation part. And that's going to be H2S. I have to write the whole compound, and then I'm going to leave some space, and I'm going to write S. Okay, and that's my half reaction for oxidation. That's all I did. Then I'm going to write the half reaction for reduction. Okay, and that's going to be, okay. Okay. Okay, oh, like my mouth's to the side? Okay. All right, let me write it, and then I'll come back, okay? So I am writing the reduction part. Okay, so all I did was take the reduction part and write it. Okay, are we cool there? So that's step 1. That's the one I just covered. We just, is she crying? Oh, so I just split it into 2 half reactions. Okay, now we're on step 2, where we're going to balance all elements except H and O. And we're going to do it for each one. Okay, I'm just going to work one at a time. I'm going to go through steps 2, 3, and 4 just with oxidation. You could do it either way. You could go step 2 with oxidation, step 2 with reduction, step 3 with oxidation, step 3. I'm going to just do oxidation first, and then I'm going to do reduction, okay? And I'm going to stop at step 6. Step 6 is a joint one. Okay, so this is our joint one. Okay, so just like in balancing chemical equations, I'm going to balance this. Okay, so in my ingredient list, I've got S and H on the left, and I've just got S on the right. Okay, so when you balance, you are going to do everything but O and H first. Okay, do not balance H, do not balance O. So what all that's left is the sulfur. I've got one sulfur on the left, one on the right. Okay, now, okay, I have 2 H's on the left, and I got a big old 0 on the right. Okay, what we're going to do, what we're using to balance H is step 4. We don't have O, so we can skip 3. Balance O. We don't have O. We don't care. Okay, so step 4, we're going to balance H by adding H plus to the equation. So I'm going to add 2H plus to the right. And now I have 2H. Okay, so we didn't need step 3 for oxidation. We just did step 4. Okay, now the last thing is we're going to balance the charges by adding an electron to the equation. Okay, so now what it means is I'm going to look at the charges of everything, the whole compound. Okay, so for H2S, the charge is 0, right? For S, the charge is 0, but now I've added 2 protons, or 2H plus, so this charge is +2. Okay, so to make both sides equal, where do you think I have to add the protons, or excuse me, the electrons? Okay, yeah, to the right or the left side? Okay, well, remember, each electron is a -1 charge. Okay, so if we want this to equal 0, 2, we're going to add 2 electrons over here, because that's going to give them a -2. -2 plus 2 is 0. So the 2 electrons are going to get added over here. Okay, so now we've added, balancing the charges by adding the electrons to the equation. 2 electrons plus 2 H plus gives you 0. So now that's balanced. So this half equation here is, okay, so we're done with steps 1 through 5. Now we're going to do the same thing for the reduction equation. Okay, the first step is going to be balance all the elements besides besides O and H. Okay, so right now we just got N and we got O. Okay, so we have 1 N on each side, so we're good. We've got 3 O on the right and only 1, excuse me, on the left and 1 on the right. Okay, so the only way we balance O is by adding water to the equation. So we're going to add a water over here, okay? But remember, for every molecule of water, that only has 1 oxygen, and we need a total of 3. So we need to add 2 waters. Okay, and now we have 3 oxygen, but now we've also added, oops, we've also added hydrogen to this equation. Okay, and we now have 4 hydrogen over here and 0 on the left. Okay, so now we have to balance the 4 hydrogen by adding H plus on the left. So we add 4. And now we have 4 H plus on the right. Excuse me, the left. And now we're balanced atom-wise. Okay, so we balance the O, we balance the H, now we balance the charges. Okay, so now we're going to count the compounds and the charges. Okay, so this is a +4, because there's 4 H pluses. This whole ion's got a -1 charge, which means we have a total of 3 on this side. On this side, we have a total of 0 plus 0, which is 0. Okay, so we only are adding electrons, which are negative. So what we're going to do is add them to the left side. So we're going to add 3 electrons over here, making it matching charges. Okay, so now we've balanced the charges. And now this equation, this half equation is done. Okay, how are we on this step? Okay, so we balanced everything except H and O. We balanced the O by adding water. We balanced the H by adding H plus. We balanced the charges by adding electrons. Okay, and now we are going to combine the equations again. Okay, because without oxidation, you don't have reduction. Without reduction, you don't have oxidation. So now we're going to take these two equations and we are going to multiply and add them together. Now, what I mean by multiply, okay, so now we're on step 6. Okay, does anybody need to copy this down before I kind of erase like the stuff in the top right? Does anybody want to copy it down or take a picture? I am recording it too, so. Okay. Okay, so what I'm going to do now is get some room together. Okay, and now we are also on the last step where we're going to multiply and add the equations together. Okay, so now your next step is to look at your electrons. Okay, because we want the electrons to cancel each other out. We have 3 electrons on the left side of the arrow over here and 2 on the right. What could we do? What common factor will help cancel them out? Okay, well, 2 doesn't go into 3, 3 doesn't go into 2 evenly. It would have to be, just like we do with balancing equations, the factor would be, the product would be 6. So we are going to now multiply this whole thing by 3. And we are going to multiply this whole thing by 2. Okay, and we're going to write out our new equations. Okay, so I'm going to write them out here. Okay, so when we multiply everything by 3, we now have 3 we now have, this is the oxidation part. We now have 3 H2S yield 6 electrons plus 3 sulfur plus 6 hydrogen. Okay, all we did was multiply 3 across the board. Okay, now for the reduction. Okay, we're going to multiply by 2 for everything. So we've got 8 hydrogen plus 2 NO3 plus 6 electrons yields NO, I'm sorry, 2 NO plus 4H2O. Okay, now we've multiplied and now we've got the two equations. Okay, so with 6 electrons on the right and 6 electrons on the left, which was how we picked our factor to multiply by. Okay, now I'm going to erase what's down here. Okay, and the last thing is we got to add the equations together and cancel out. Okay, so when I add them together, okay, remember, I'm looking at the arrow. I'm adding everything on the left of the arrow first. Okay, so that's going to be 3H2S plus 8 hydrogen, that's from the reduction equation, so this is from the oxidation equation, plus 2NO3, -1, plus 6 electrons. Okay, so this all came from the reduction equation. Yields 6 electrons plus 3 sulfur plus 6H plus, and this all came again from the oxidation equation, 2NO plus 4H2O. Okay, let me just double check myself that I did everything right. Checking my work just to make sure I was doing it. Yeah. Okay. Now the last thing is we've multiplied to get the same number of electrons. We've added the two equations together, and now we're going to cancel equal things on the opposite sides of the arrow. Okay, so here's my arrow. First thing I'm going to cancel out is my electrons. Okay, and I also see a common thing with the 8 hydrogen and the 6 hydrogen. Okay, so we can cancel out the 6 over here, leaving 2 hydrogen over here. And then we're going to write our final redox equation, which is going to be 3H2S plus 2NO3. I forgot that, plus the 2H plus yields 3S plus 2NO plus 4H2O. And this is going to be your final answer. Okay, for our charges, we've got -4, we've got +1, so then the nitrogen has to be a +3. Okay, so we got nitrogen +3. I here is going to be -1. It's going to be whatever charge the ion is. Nitrogen here is going to be +2 because this is -2. And then the I is 0. Okay, so the next thing we do is we look at what changed. Don't worry about oxidation or reduction, but it looks like the nitrogen went from +3 to +2, so that's definitely a change. And it looks like the I went from -1 to 0, so that's definitely. Okay, now we got to see which one is losing electrons. So oxidation is losing electrons. Okay, so we went from +3 to +2. Is that gaining an electron or losing? So that's gaining. Okay, so then nitrogen is being reduced. Okay, so I'm going to write nitrogen is reduced. And then let's make sure that the iodine is getting oxidized. It's losing an electron, and it is -1 plus 1. So iodine is oxidized. Okay. So now I think, is everybody clear on that part? Okay, so now, okay, so next step Okay, take a minute before I write it down, break it down into your two separate equations. So go on to step 2. Okay, so let's write our two separate equations. For oxidation, we should have I negative 1 goes to, need a little more room here. No, I'm talking, I know you're probably losing my voice too. I to the negative 1 goes to I2. And then for the reduction, you should have HNO2 goes to NO. Okay, so that's the two half reactions. Step 1 is done. Okay, now the next thing is to balance. Okay, we have to balance all the elements except H and O. So let's just work on oxidation first. Okay, so we have I. So we just have to balance the I. We've got 2 on the right and 1 on the left. That means we have to put a 2 here. And now it's balanced. There's no H in the equation. There's no O in the equation. So we're good. Okay, so we don't even need steps 3 or steps 4. And now we got to balance the charge. Okay, so be careful. We just put a coefficient in front of the 2, which means the charge now on the left side is going to be a total of negative 2. The charge on the right side is a big old 0. Okay, so we want negative 2 to equal 0, which means the only thing we can do is add electrons. We're going to add 2 electrons to the right, and that's going to give us a negative 2 charge to match the left side. So that's where we're adding our electrons. Okay, so we've done steps 2 through 5 for oxidation. Now we're going to do 2 through 5 for reduction. Okay, so we're going to balance first the atoms. We're going to do everything but, we're going to do N first, then we're going to do O, and then we're going to do H. Okay, so on the left we have 1N, 2O, 1H. On the right we have 1N, 1O, and no H. Okay, so N is already balanced, and that's the only element other than oxygen and hydrogen, so we'll go down to the oxygen. Since we have 2 on the left, we've got to balance it by adding a water on the right. So now we have 2 oxygens on the right, but we now also have 2 hydrogens on the right. Okay, so we go back and we need to add an H plus on the left to now balance up. Okay, and Monday we're going to talk more about the whys of what we're doing. Okay, so now we have balanced atoms. Now we got to balance charges on the left and the right. Okay, so on the left we've got +1, and then the HNO2 is going to be a 0. So we have a total of +1. On the right, we have 0. Okay, so in order to balance it out, we have to add 1 electron to the left, making it now 0. Okay, so now we've completed steps 2 through 5 for both oxidation and reduction. Okay, the next step is to get the electrons to have the same factor. So we've got 2 electrons on the top one and 1 on the bottom. Okay, so we're going to multiply the bottom by 2. That's what we're going to do now. So we're going to take this and multiply everything by 2. We don't need to do that to the top one because we already have 2. Okay, now I'm going to move some of this so we have some space. Get rid of some of our initial work here. Okay, and now I'm going to rewrite my 2 equations. Okay. For the oxidation, I've got 2 I negative 1 makes I2 plus 2 electrons. Okay, for the reduction, I'm going to multiply now. I'm going to have 2H plus 2HNO2 plus 2 electrons yields 2NO plus 2H2O. Okay, now the final thing is to add everything together. Okay, so now I'm doing the left side of the arrow first, and I have 2I negative 1. Okay. Then I'm going to do the right side, the left side of the arrow for the reduction, 2H plus 2HNO2 plus 2 electrons. And that's all from the left side of the arrow for the reduction. And then I'm going to do the right side. So that's going to be I2 plus 2 electrons plus, okay, and that's all from the oxidation, plus 2NO plus 2H2O. And that's from the right side of the reduction. Okay, let me just check my work just to make sure I added them properly. Looks good so far. Yep. Okay. Now I'm going to get some more room down here, if you don't mind. Okay, and now we got to cancel out things on the opposite side. And then we're going to write our final equation. Okay, so we can cancel out, let's see what we can cancel out. We can cancel out, of course, our electrons, and I think that looks like it. Okay, so our final equation will be 2I negative 1, 2H plus 2HNO2 yields I2 plus 2NO plus 2H2O. And this is going to be our final redox reaction.